Let's talk for just a minute about the area of a sector formula. A sector is like a piece of the pie. And so when you're finding the area of a sector, you really find like a part of your area of your whole circle. And so you just have the fraction you need of the area of the circle. So for instance, if this was 1/3 of my circle, I would just need to multiply the area of my circle by 1/3 to find the area of just that part. So let's look at just a few examples. I don't think it takes very many to get this formula, and we can practice more together. So for example 1, we want to just find the area of these two sectors. I gave you one small one and one larger one on purpose. And so for the area of sector in number 1, we would just put the portion of our circle. So usually they'll give us enough information to know the degree of that angle. So we know it's 60 degrees because that was given, over the total area of our circle, which is always 360 degrees, times the area of our circle, which would be pi r squared, so pi times 10 squared. And so you have 60 over 360 will reduce. And so we have 1/6 of our circle. And you might be able to recognize that just by looking at it and know that 60 is 1/6 of our circle, and go ahead and write that here, and that's fine too. And then times 100 pi. So we could reduce it and either leave it in terms of pi or as a decimal. So I'm just going to write both. 1 times 100 over 6 would reduce to be 50 pi over 3, or the decimal I got was 52.4. So either one of those is good. It's good to practice both. For number 2, they gave us that the diameter was 14. So we could conclude quickly that the radius would be 7, and that's going to help us find the area of the circle. And then we need to look at what the angle measure would be for this sector they're talking about. So it's a very large section of the circle. It's everything except for this 90-degree angle. And so we would first say 360 minus 90 is 270 degrees. That's the measure of our sector angle. We put that over the total, which is always 360. And then multiply it by pi r squared, which is just 7 for our radius because they gave us the diameter was 14. And now we just need to clean that up. So in cleaning that up, let's see, I got that 270 over 360 is 3/4. And again, you might be able to just put the 3/4 because you see that 3/4 of this circle is shaded green. So if you go directly from that picture to 3/4, that's okay too. And then times 49 pi. So I got the number 147 pi over 4. Or my decimal was 115.5. My 1 got erased a little bit. Let me write that back. But again, it's good to write it in both forms. Leave it in terms of pi in case you see it that way, and practice getting a decimal to make sure you get the right decimal. Now, what if they ask this question? Find the area of a segment of a circle. And so they would have to give us some information to help us out here unless we've done some trig work and we could figure out things that way. But in case they put it in this section, I've added in some extra information to figure this out. So the idea is you want to find the area of that sector of your circle and then just subtract that triangle that's sitting right there blocking part of that sector. So to find the area of the sector, we do the same thing we've done here. And they told us the measure of angle ABC is 120. So 120 over 360, or you might see that that's 1/3 of my circle. So I would put that. And then pi r is 8, so my radius was equal to 8. So let me write that a little better. If the radius equals 8, that's times pi 8 squared. So 1/3 times 64 pi would just give me 64 pi over 3. Or we could leave it, let's see, I got 67.02. And that might be easier for this next part because the next part is to subtract the area of the triangle. So the area of a triangle, in case you don't remember, is 1/2 base times height. So I had to give you some information for the base and the height to not take up too much of your time. And I know you can do Pythagorean theorem. So the base is actually AC. Notice like that's the bottom of this triangle. It's just turned upside down in the picture. The height of it I gave you was 6, but we have enough information to use the Pythagorean theorem to figure out the distance from right here to A. We haven't labeled that anything, so we could say like that's letter D. And so 6 squared plus 8 squared equals AD squared. And so we add that up and we get 100. So AD is equal to 10. But that's only half of the base of this triangle, so we need to multiply that by 2. So our area of our sector minus, and now we can figure out the area of the triangle would be 1/2 base, which is 10 plus 10, which is 20, times the height, which is given, which was 6. So 67.02 minus half of 20 is 10, and 10 times 6 is 60, would just leave us with an area of 7.02, which is small, but it should be small because you've taken that part of a circle and then you also subtracted out that whole triangle. So you're not left with a whole lot, and that's all we need to do. So find the area of the sector when you're given a figure like this and subtract that triangle, or they could potentially